Okay, let's take a look at what happens if you were to study the mono-substitution of propane. So this is a propane structure. If you look at the mono-substitution, we will either produce only two possible radicals, which is either this or this. The reason is because if any of these 3H is removed, you'll get this radical. Similarly, if you remove any of this hydrogen here, you will also get this radical. To produce this radical, you will have two of this hydrogen. Either one of these is removed, you will produce this radical. So as far as propane is concerned, if you were to undergo mono-substitution in the presence of chlorine, there can only be two mono-substituted products, either this or this. And the ratio at which they exist will be actually 1:3. Why? Because the ratio at which the number of hydrogen to be removed to produce this or this is 2:6. If it's 2:6, then we kind of expect this to be 1:3. This will be the answer if no further information is being given. However, in reality, there's actually another factor. The other factor to study is to study the stability of the radical that's produced between these two. You realize that radicals, after all, is electron deficient. So this carbon will be looking for electron to be given to it. And given the fact that it has two alkyl groups and understanding that alkyl groups are electron releasing, you will find that this radical is more stable because it has two radical groups releasing electron to the carbon radical. Whereas in this case, there's only one alkyl group, which is actually releasing electron to the carbon radical. Hence, because of this, this is expected to be more stable. So in reality, you will find that the rate at which this is produced could actually be 2 times more than this. So let's make an assumption. So since this is actually more stable, the rate at which this radical is produced versus this will be 2:1. All right. In that case, the amount that's produced is no longer 1:3 anymore. Now to work out the ratio at which what will be the ratio of the mono-substituted product, we will have to use 2 times 2. So this will be 2 times 2, and this will be 6 times 1. So hence, if you were to pare down the ratio, you will end up as 2:3. So the answer for this question now, if given the rate of radical, if the comparative rate at which this radical that's been produced is provided, then the answer will be 2:3.